In the name of God, hello dear students, welcome back to Thinkable Physics. This is my YouTube channel. I'm Masoud and I'm at your service to explain one more subject about the behavior of gas, which is called pressure. So the title of our subject is pressure. Let's get started. I want to read the subject and highlight the important information, and after that we will discuss it together. The amount of force exerted on a given area of surface is called pressure. This is the definition of pressure. Let me highlight for you. Amount of force exerted on a given area of a surface. Let me show you some simple machines or devices in our daily life. These devices actually make use of pressure. Let me show them to you. For example, there is a syringe, right? This syringe consists of two parts. There is a piston. The pistons move back and forth inside the cylinder. Piston and cylinder. So whenever you exert force on the piston, right? It means actually whenever you exert force on the piston, right? So you apply pressure on the piston. What do I mean by this? It means pressure depends on two factors. By means of two factors, you can apply pressure on the syringe. What's the first factor? Force of your hand. Force of your hand. Actually, this is the applied force. What do you say about the area? So pressure depends on two factors, area and force, right? There must be an area actually to apply force on it. So what is the force? What's the area? The force is the force of your hand. And the area is the cross-sectional area of the piston. This is the area. So force on area is called pressure. So by means of this action, you apply pressure on the syringe. Right. One more example. So there's a marker, right? The marker looks like the syringe. It consists of a piston, moves back and forth inside the piston, and there's a piston. So I want you to apply pressure on the marker. How do you apply the pressure? By two factors, as I told you. By exerting force on the cross-sectional area of the piston. This is your force actually. You can apply it by your thumb, by any finger, you can apply it. And by this action, you can make a pressure on the marker. One more thing. We have a bicycle pump. This bicycle pump actually, like the previous example, consists of two parts, piston versus cylinder. So I want you to apply pressure on it. How do you apply pressure on the piston actually? Just by exerting force on cross-sectional area of the piston. That's why this is so the process of pumping is taken place by the applying pressure on the piston of the pump, right? So these are examples. These are common examples in our daily life, actually, that unconsciously you apply pressure actually on these objects, right? Let's actually get back to the text and keep going the reading. You can think of pressure as the number of times that the particles of a gas hit inside the container. Hit inside of the container. So this is the origin of pressure. Where does pressure come from? It comes from the number of times, right? Number of times that the particles of air hit inside the wall of the container. Let me highlight for you. And I told you this is the origin of pressure. Pressure is the number of times the particles of gas hit inside the actually container, inside wall of the container. The balls in figure 2 are in the same size. I want to show you two balls, but actually let me read it, and after that I'll break it down for you. It says the balls are in the same size, which means they can hold the same volume of air, right? Which is a gas. So what do you understand from this line? And I explained it for you in previous lessons. We said that size means volume. So if you hear the word size means volume. In our daily life, we don't use volume, we use size in our daily speech. But in science, instead of size, we use volume. That's why size is equivalent to volume, right? Notice, however, there are more particles of gas in the basketball. Actually, I'm gonna show it to you. It's not a basketball. We have a football. We have a football versus a beach ball. I'm gonna show it to you. Let me read the subject, and I'll break it down for you. It says there are more particles of gas in a basketball, and I wanna, let's say, change it to the football, because actually the example is not about the basketball. We have a football here. The figure actually shows a football. I want you to correct it. So wherever you observe a basketball in the reading, in the text, turn it to the football. Change it to the football. It says there are more particles of gas in a football than in a beach ball. Right, let me highlight for you. More particles of gas actually in a football than in a beach ball, right? There are more particles of gas actually in a football compared to the beach ball. So more particles hit the inside surface of the basketball, and I told you it's the football, than hit the inside surface of the beach ball. So more particle, actually more collisions. More particle hit the inside surface of the actually ball in the case of football, right? When more particles hit the inside surface of the basketball, the force on the inside surface of the ball increases. So more particles leads to the what? More particles leads to the more collisions. More collisions leads to the more force. And at last, more force actually leads to the high pressure. So they are actually connected to one another. They have to do with one another. It starts from the number of particles. Number of particles create actually more collisions. More collisions create actually more force, and eventually more force on the inside wall of the container creates a high pressure. Let me highlight some actually information for you. More particles. I want you to highlight these information, and it's easy. It's not difficult. If you read it, it's very easy. It's nothing. More particles hit the inside surface of the basketball than hit the inside surface of the beach ball. When more particles hit the inside surface of the ball, right, basketball, the force increases, right? The force increases. I'm going to summarize it for you in a when we finish the reading, right? So this increased force leads to greater pressure. So at last, or eventually, finally, increased force gives rise to the high pressure, greater pressure, which makes the basketball feel harder than the beach ball, right? So which makes the basketball feel harder than the beach ball. So this is about the text. Let's move on to the figure, and I want to explain it on the figure, and after that we will finish the lesson, right? So we have two we have two balls, right? We have two balls. We have football versus beach ball. If you take a look at the figures, actually, if you take a look at each figure, you see that actually more particles are present in the football than in a beach ball, right? So here we have more particles, right? More, let me write it for more particles of air. More particles leads to the what? More particles leads to the more collisions, right? More collisions create more force, and more force applies high pressure on the inside wall of the container. So I can say more particles leads to the what? Leads to the high pressure. High pressure. I use the abbreviation of pressure instead of writing the pressure. Instead of writing the word, I used P. So P capital stands for pressure. So more particles, high pressure. I can say the more the particles, the more the pressure. What do you say about the beach ball? If you take a look at the particles of beach ball, you observe that there are fewer number of the particles than in a football. Let me write it. So here on the figure, actually, fewer particles. So few particles of air are existed inside the beach ball. So few particles, as I told you, leads to the few collisions. Few collisions actually collision with the inside wall of the container. I mean. So few particles leads to the few collisions, and few collisions create, let's say, less force, and eventually, actually, we have a less pressure, we have a low pressure. So I can say the fewer the particles are, the lower the pressure is. So few particles leads to the what? Leads to the let's say low pressure, right? So I can say there's a direct relationship between the number of particles and the pressure, right? Increasing number of the particles leads to the what? Leads to the increasing the pressure. Decreasing the number of the particles leads to the what? Leads to the actually less pressure. I want to show you two balls. So I've brought two balls, football and a rubber ball. Let me show them to you. There are two balls, football versus rubber ball. So there are more particles inside the football than in a rubber ball. If you touch the actually surface of the ball, it feels hard. Actually, it feels harder than the rubber ball. But if you touch the number of the actually rubber ball, actually it looks very soft. So this one looks very hard. Football looks very hard if you touch it, and the actually rubber ball feels very soft if you touch it. I want you to think about my question. I have a question for you. I want you to think about it, and this is my question: why does a football feel harder than a rubber ball? Or why does the rubber ball feel actually softer than the football? That's all, guys, for today. Thank you very much for watching this video, and bye bye.